Well, this is the second exercise of Unit 6 about managing inventory. This is quantity discount models. The aim of this kind of exercises is to identify which is the best quantity to buy because the provider has different offers for the company. According to the quantity, the price is going to be lower. As much as higher the quantity, the lowers the price. In these cases, we are going to need the information of D, which is annual demand, S, which is ordering cost, and I, which is the percentage of holding cost. All this information, the exercise says all this information. For example, if this is a coffee shop and they use 4,900 kilos of coffee per year, this is the annual demand. They also say that each time they order coffee, it costs them 50. 50 is the ordering cost, and the cost to hold inventory is 20. So 20% is the percentage of holding cost. Here we need to, with this information now we can discover which is the value of H. How can we do that? This is the formula of H is I times P when P is the price. Now we know it's 20%, 0.2 times the price. And the same is going to be for the other two quantities. That is the first step. Well, the second phase of this exercise is divided into a step to identify which is the optimum quantity for every possible scenario. We have the formula of Q here, so we just have to replace the values to estimate every Q, the Q for every possible quantity and possible price. It is root. In my case, this is raíz because my computer is in Spanish, but in your case, if you are using Excel, you are going to find root as a formula. So the formula is 2 times D, which is 4,900, multiplied by S, which is 50, divided by IP. We already know that IP is the same H. We have calculated H before, so we can use this value. The same calculation we have to do for the other two possible scenarios. Second step of this phase is to accommodate, like to adapt the quantity to a possible quantity we can order. In the first case, it says that the optimum quantity is 700, and the provider says that we can buy between 1 and 999 units. So we have no problem if we deliver an order for 700 units. The second case, the optimum quantity is 703, but the provider has like conditioned that the minimum quantity for to get this price is 1,000. So if we decide to use this optimum quantity, we need to order 1,000. And the same for the other scenario where the minimum quantity is 4,000. This is the way how we get this step 2. And the other calculation we are going to do is with these numbers. Finally, we are going to estimate the total cost for every possible quantity. The formula for total cost is this, but in this exercise, the book divides these calculations for ordering cost, holding cost, and purchase cost. Inside of the formula, we have the value of ordering cost, this is holding cost, and this is purchase cost. All of this is going to give us the total cost. So for ordering cost, we just have to replace the formula. We have D, which is demand. That now we know it, demand is 4,900 divided by Q, and Q in this case is 700 times S. We know that S is 50. Here is S. The same formula for the other two cases. Same for the holding cost. This part is holding cost. Q divided by 2 times IP. Now we know the IP and H are the same. Q, this case is 700 divided by 2 IP, which is this one. And replicate the same calculation for the other scenarios. And the purchase cost is P, which is price, times D, there is demand. So price is this, and demand 4,900. Total cost then is going to be the sum of ordering cost plus holding cost plus purchase cost, and the same for the other two. Now that we have the 3 total costs for every possible quantity, we discover that the second one, in this case Q2, is the one that gives the lowest total cost. So for the company, it's better order 1,000 units to get the price of 4.95, and with this information, with these values, the total cost is going to be this one. And that's all.